A powerful heavy motorcycle races across mountain highways, showcasing the final result of thousands of manufacturing steps and precision engineering processes. Thousands of precision-engineered components work together to create power, reliability, and performance. Today we follow the complete journey from raw materials to final road testing. Every motorcycle begins with engineering, planning, and digital design. Frame dimensions are spot on. Let's check the engine bay. Every component is designed and validated before production. Before any metal is cut or any component is produced, engineers create a complete digital version of the motorcycle. Heavy motorcycles are used for transportation, long-distance touring, adventure riding, professional services, and recreational travel worldwide. A modern heavy motorcycle may contain more than 2,000 individual components working together as one machine. The journey begins deep inside massive iron ore mines where the primary material for steel production is extracted from the earth. After extraction, iron ore is transported from the mine to steel production facilities where it will be refined and processed. The extracted iron ore is transported to a steel mill where it is transformed into the high-strength steel required for motorcycle manufacturing. The finished steel is formed into tubes, sheets, and coils before being shipped to motorcycle factories. The documentary shifts to another critical material required for motorcycle production: aluminum. Aluminum begins its journey in bauxite mines, where the raw ore is extracted for future engine and wheel production. At specialized refineries, bauxite ore is processed and refined into aluminum suitable for industrial manufacturing. Refined aluminum proceeds toward casting ingot production. The refined aluminum is cast into standardized ingots that can be transported to manufacturing facilities. The documentary now shifts to another essential motorcycle material: rubber. Natural rubber used in motorcycle tires begins in rubber plantations where latex is collected from mature trees. Modern motorcycle tires often combine natural and synthetic rubber to achieve durability, grip, and performance. Specialized engineering plastics are produced for motorcycle fairings, electrical housings, and protective components. Attention shifts to copper, the foundation of motorcycle electrical systems. Copper is processed into precision electrical wiring used throughout the motorcycle's electrical network. Finished copper wiring is delivered to electronic suppliers for component assembly. Modern motorcycles rely on advanced electronic systems that monitor and control critical functions. All major raw materials have now been produced. The next sequence follows their transportation through global logistics networks toward the motorcycle factory. After production, raw materials and industrial components begin a global journey through international logistics networks before reaching the motorcycle factory. Rail networks move large quantities of industrial materials efficiently across long distances. The final stage of transportation brings raw materials directly to the motorcycle manufacturing facility. Materials are unloaded and transferred to receiving docks for inspection. Every incoming material is unloaded, identified, and prepared for inspection before entering production. Every shipment must first pass receiving and verification procedures to ensure traceability and quality control. Every shipment is digitally tracked to ensure complete inventory control throughout the manufacturing process. Before steel enters production, it undergoes rigorous inspection to ensure it meets engineering specifications and structural requirements. Precise thickness verification ensures every steel component can meet safety and durability requirements. Even small deviations can affect motorcycle frame strength, alignment, and long-term performance. After inspection, materials are categorized according to strength, dimensions, and intended manufacturing purpose. Sorted materials are scheduled for production and connected to digital manufacturing systems. Modern motorcycle manufacturing relies on digital engineering data to guide every production step with precision. Every cut, bend, weld, and machining operation is guided by these digital instructions. Let's confirm the tolerances for the frame welds.
They're within spec. Here's the folder.
And the steel certs? Any issues? Looks good. The steel is approved for frame production. Frame production begins as high-strength steel tubes are delivered to automated cutting systems. Computer-controlled laser systems cut steel components with exceptional precision. After cutting, the steel tubes are shaped into precise geometries that will form the motorcycle's main frame structure. Every formed frame component is inspected to verify dimensional accuracy before assembly. The scene highlights the importance of dimensional precision. Once approved, the individual frame sections are organized into complete frame sets ready for welding. Advanced robotic welding systems permanently join the frame components into a single high-strength structure. Each weld must achieve maximum strength while maintaining precise dimensional accuracy. With welding complete, the motorcycle frame emerges as a unified structure ready for verification. The completed frame moves to dimensional verification to ensure perfect alignment. Before continuing production, the finished frame undergoes final dimensional inspection. The aluminum is heated to temperatures exceeding 650 degrees Celsius until it becomes molten and ready for casting. High-pressure die casting machines transform molten aluminum into precise engine casings. Newly cast engine components must cool and stabilize before further processing can begin. Every engine casting is carefully inspected to ensure it meets structural and dimensional requirements. Approved engine castings are transferred to the CNC machining department where precise engine features will be created. Although casting created the basic shape, precision machining is required to produce the exact dimensions needed for engine operation. Computer-controlled milling machines create flat surfaces, mounting points, and critical engine features with exceptional accuracy. After milling, specialized boring machines create the highly accurate internal cylinders and bearing housings required for engine performance. Rotating engine components require perfectly machined surfaces to ensure smooth operation and long-term durability. Every machined engine component is inspected to verify that it meets exact engineering requirements. With engine components approved, attention shifts to another critical powertrain component, the crankshaft. The crankshaft is one of the strongest components in the motorcycle. It begins as heated steel that is forged under immense pressure. After forging, the crankshaft undergoes extensive machining to achieve precise dimensions and balance. The finished crankshaft moves to balancing equipment for final verification. Even the smallest imbalance can cause vibration, so every crankshaft is carefully balanced before engine assembly. With the crankshaft complete, production continues with transmission gears that transfer engine power to the rear wheel. Transmission gears are manufactured with extreme precision to ensure smooth and reliable power delivery. The newly cut gears move to heat treatment where their strength and durability are enhanced. Freshly machined gears are not yet strong enough for years of operation. Heat treatment increases hardness the steel's internal structure, enabling the gears to withstand thousands of kilometers of operation. Every gear is inspected to ensure flawless tooth geometry and proper hardness before assembly. With major engine and transmission components completed, the suspension system helps maintain stability, rider comfort, and control under varying road conditions. The suspension system helps maintain stability, rider comfort, and control under varying road conditions. Before installation, suspension systems undergo testing to verify performance and reliability. With suspension manufacturing complete, production continues with wheel and tire manufacturing. Motorcycle wheels begin as aluminum castings designed to provide strength while minimizing weight. Motorcycle wheels begin as aluminum castings designed to provide strength while minimizing weight. Proper wheel balance is essential for stability and rider safety at high speeds. With wheels completed, the next stage begins, manufacturing the tires that will connect the motorcycle to the road. Motorcycle tires begin with carefully engineered rubber compounds designed for grip, durability, flexibility, and safety. Heat and pressure permanently strengthen the tire through a process known as vulcanization. Every tire undergoes rigorous inspection to ensure safety and performance. With wheels and tires completed, manufacturing continues with fuel tank production and body components. The fuel tank begins as flat steel sheets that are transformed into complex three-dimensional shapes. Many exterior motorcycle panels are manufactured using high-precision plastic injection molding. Each fairing panel is finished and inspected before entering the paint department. Completed tanks and fairings now move to the paint shop, where appearance and corrosion protection are applied. Before paint can be applied, every fuel tank, frame, and fairing must be thoroughly cleaned and prepared to ensure perfect adhesion and long-term durability. A protective primer layer is applied to improve paint adhesion and defend against corrosion. The motorcycle begins to acquire its final appearance as color coatings are applied with exceptional precision. A transparent protective layer is applied to enhance durability, gloss, and resistance to environmental damage. Heat curing permanently bonds the paint system to the motorcycle components. With painted components complete, production shifts to the motorcycle's electrical and electronic systems. The wiring harness acts as the motorcycle's nervous system, connecting every electrical component throughout the machine. Modern motorcycles rely on sophisticated electronics to monitor performance, safety, and rider control systems. Before installation, every electrical system is tested to ensure flawless operation. All major motorcycle components are now complete and approved. The manufacturing journey, its most important phase, final assembly of the heavy motorcycle. After months of material processing and component manufacturing, the motorcycle finally begins to take shape on the main assembly line. The engine is the heart of the motorcycle, and its installation is one of the most critical steps in assembly. With the engine installed, suspension components are added next. Front and rear suspension systems are installed to provide stability, comfort, and handling performance. The motorcycle receives the wheels and tires that will ultimately connect it to the road. Advanced braking components are installed to ensure safe and controlled stopping performance. Advanced braking components are installed to ensure safe and controlled stopping performance. The motorcycle's nervous system is installed, connecting power, sensors, safety systems, and rider controls into one integrated network. Every critical fastener is checked to ensure it meets exact engineering specifications. With all systems verified, the motorcycle moves to final assembly completion. Thousands of individual parts have now become one complete heavy motorcycle. Before any motorcycle leaves the factory, advanced inspection systems search for even the smallest defects. Before any motorcycle leaves the factory, advanced inspection systems search for even the smallest defects.
Engineers verify that the braking system can safely stop the motorcycle under emergency conditions.
To simulate years of road use, motorcycles are exposed to extreme vibration and durability tests. Motorcycles must withstand harsh environmental conditions including heat, cold, humidity, and water exposure. After environmental validation, electronic safety systems undergo final verification. The final quality control stage verifies electronic safety systems and digital controls. Having passed every inspection and test, the motorcycle is approved for final finishing, packaging, and shipment. After passing all quality control tests, the motorcycle receives its final cosmetic preparation before shipment. Headlights, indicators, controls, check. Brakes and suspension are responsive. Fluids, tires, electronics, paint, good. Assembly and ID numbers verified. Approval complete. Ship it.
Special protective materials are applied to safeguard the motorcycle during transportation across the world.
Tracking information is attached so every motorcycle can be monitored throughout its global journey. The packaged motorcycles are cleared for storage and worldwide distribution. The first stage of distribution begins as motorcycles are loaded onto transport vehicles. Loaded motorcycles begin their journey through regional transportation networks. Rail networks move large volumes of motorcycles efficiently across long distances. International shipments continue toward export terminals and seaports, from mined minerals and molten metal to open roads and endless horizons. This is the incredible journey of how heavy bikes are made.